Besu is powerful, but it is not the default answer. In this topic, we'll learn how to judge fit, where shared trust, governance, and auditability create value, and where performance limits or unclear trust boundaries point to a simpler architecture. Up to now, you've built the core context: what Besu is, how public, private, and permission networks differ, and why enterprises care about governance, permissioning, and interoperability. Now we move from understanding Besu to deciding when to use it and when not to. Before choosing Besu, start with trust. Who needs to trust whom? If several independent organizations need shared truth, auditability, and verifiable history, Besu may fit. If one party controls the data and the process, a database is usually simpler. Settlement across organizations is one of the clearest Besu use cases. Banks, clearinghouses, and companies can submit transactions to a shared permission network where smart contracts enforce settlement rules. Each participant can verify the final state independently, reducing delays, disputes, and manual reconciliation, while still controlling who can join and validate. Tokenization is another natural fit because assets can become programmable records of ownership or value. A token might represent an invoice, a bond, loyalty points, carbon credits, or a vehicle fleet. Smart contracts define who can issue, hold, or transfer those tokens, while permissioning limits participation to approved organizations. Supply chains also work well because no single company owns the full journey. With Besu, each handoff can become a shared event: origin, custody transfer, inspection, certification, and delivery. This creates a tamper-evident history for recalls, provenance, audits, and compliance, especially when partners agree upfront on data standards and governance rules. Regulated consortiums are a strong fit when multiple organizations need shared infrastructure without giving up control. Think banks, insurers, healthcare networks, energy firms, or public agencies. Permissioning limits participation to approved members. Governance defines who can validate, deploy contracts, or change rules. Auditability gives regulators confidence that activity can be reviewed and traced. Besu can also support a shared audit trail where several organizations need the same trusted record of events. Instead of one party owning the history, each participant can verify what happened and when. Often, the chain stores timestamps, approvals, and document hashes, while the full documents remain off-chain. That gives auditors evidence without creating a single point of trust. Decentralized identity fits when multiple organizations need to trust credentials without relying on one central identity provider. Besu can anchor identifiers, credential schemas, revocation registries, and cryptographic proofs. The key design point is privacy. Personal data usually stays off-chain, while the chain provides a shared trust layer for verification, onboarding, and access control. A common mistake is choosing Besu when the real need is centralized data storage. If one organization owns the data, writes the records, and controls access, a traditional database is usually faster, cheaper, and easier to query. Besu becomes valuable when multiple parties need shared state without one trusted controller. Immutability alone does not justify the added governance, cost, and operational complexity. Another mistake is using Besu where ordinary middleware would be simpler. Message queues handle fast, high-volume, asynchronous communication. Workflow engines handle approvals, task routing, and process automation. Besu serves a different purpose: shared state that multiple parties can independently verify. If every step is internal, trusted, and latency sensitive, blockchain confirmation adds cost without much value. Besu should not be treated like a general-purpose database or a high-speed message bus. Put proofs, hashes, and business-critical state on-chain. Keep large files, raw sensitive data, and analytics workloads off-chain with proper indexing. Be realistic about throughput and latency as well. Consensus, node hardware, and network topology all impose limits. If the use case needs millisecond responses or massive event streams, design a hybrid architecture, not a bigger smart contract. Start the decision process outside the technology. First, identify who participates and whether they operate in different trust domains. Then ask whether a shared ledger would reduce reconciliation, disputes, fraud, or coordination costs. The strongest Besu candidates are situations where no single organization should control the system, but everyone needs the same reliable state. If blockchain cannot create measurable business value, it is probably complexity, not architecture. Once the business case is clear, test whether the network can be governed and operated safely. Define who can join, who validates, how contracts change, and how disputes are resolved. Classify data carefully: shared, restricted, encrypted, or kept off-chain. Then match Besu's performance profile to your throughput, latency, finality, and integration needs. Finally, account for the real operating model: nodes, monitoring, security, upgrades, compliance, support, and total cost over time. The core lesson is simple. Choose Besu for shared trust, not technical fashion. It fits when organizations need verifiable shared state, auditability, programmable assets, and governed participation. Avoid it for simpler centralized, low latency, or high throughput needs. Next, we turn that decision into architecture, starting with nodes and consensus.